All right, 11D and G. I've given you the rules. You will have the integration rules on your formula sheet at the end of your exam, but it's about knowing how to apply them. Hopefully by now you should be able to see the antiderivative is just backwards of what you did for derivatives. So normally if I asked you to derive e to the kx, you would say derive the inside, which then k comes to the front, and then derive the outside. So when you're antideriving, it's the other way around. Instead of k coming to the front, then now you're dividing it by k. That's why they all have 1 on k. Okay, so it's always because there's a coefficient in front of x. If you did the chain rule, there would have been a k at the front. So now when you're going backwards, there should be a 1 on k at the front in each one of them. The maybe next confusing part is when you're deriving an antiderivative. Remember, derivative of a sign is a positive cos. That's why the antiderivative of cos gives you a positive sign. And so now it's reversed. Remember, derivative of cosine gives you the negative sign. So therefore, the antiderivative sign gives you the negative of cos. So it's just the backwards version. Those likely will come up in the exam. Those are the ones I often see because of that little nuance. E to the kx is pretty common. And then this one is not as common. But it'll be good to see. So again, derivative of tan gives you second squared. Then the antiderivative of second squared gives you tan. Okay? Now you've got the rules in front of you. Let's have a look at the first one. Let's look at the first example. So you're trying to antiderive e to the x plus e to the negative x, but all squared. Had I not put in the squared, then it would have been pretty straightforward. You could have, if I didn't put in the square, you could have just done antiderive e to the x dx plus antiderive e to negative x dx. It's almost like doing a power rule separately for each term. Then you can antiderive each term separately. What's the problem? You have the square. So you can't do this now. What is the strategy? What's something you're going to come up with? It's kind of like chain rule in a way. How would we do this? Let's pick someone. Let's go with Adonis. What do you do if you have this problem with the square? Very good. That's the only thing you can do, okay, at this point. Unless you're doing special, there's probably other ways, which I'm unfamiliar with, but I just know for methods, we don't have a technique for this, so you have to preliminarily just go back to your basic skills. Expanding it is the first step. Why expanding it? Because you break it into their separate terms. So here, let's expand it. If I expand it, you can treat this as your a plus b, and if you're squaring it, remember the rule, perfect squares expansion, a squared plus 2ab plus b squared. So that means I'm squaring the first term. So e to the x squared is e to the 2x plus 2 times a times b. So this is my a and that's my b. Times them together and then put a 2 at the front. So here we go. I got 2 e to the x times e to the negative x. And then plus b squared, which is squaring the last term, which ends up being e to the negative 2x delta x. Great. Now we've expanded them, and they are now much more familiar. We can do the first one because I gave you the rule for it. Let's break it up. I'm going to break it up into little sections. So here we go. Antiderive e to the 2x delta x. Using the rule that I've given to you, what would the answer be? Can I have, let's go with Una. Using the rule I've given you on the page, what's the antiderivative of e to the 2x? Beautiful. Okay, so if we just go back to the rule, for those who are watching the video, you can see k is the coefficient of x, so it's 1 on k, e to the kx. Don't need to put the plus c yet because I'm going to antiderive them all individually. So here we go. Let's do the next one. If I antiderive now 2, now before you do this one, what's 2 e to the x times e to the negative x simplified to? Can I please have, let's go with Phoenix. What does this simplify to? 2 times e to the x times e to the negative x. What does that simplify to? 2. Yeah, very good. For those who weren't sure, remember when you're multiplying indices, Same bases, add the powers. X plus negative x becomes 0, so e to the 0 is 1. That's why 2 times 1 is just 2. Now this is going back to the last exercise that you did. What is the antiderivative of a constant? Can I please have, let's go with Krish. What's the antiderivative of 2? It is 2x. Very good. Okay, so again, for those who've forgotten how to do this, you can treat this as x to the power of 0. And antiderivative of power functions, instead of minusing 1 to the power, you add 1 to the power. So add 1, and then divided by n plus 1. Okay? And so that's how we end up with 2x. That was from our last exercise. And then the last one is pretty much following on what Una had done before. It's pretty much the same thing, except it's got a negative power. E to the negative 2x dx should then give me, what's this, negative half e to the negative 2x. Looks pretty good there. And then from here, we can then put it all together. So therefore, the antiderivative, and remember, this is an indefinite integral. It doesn't have any intervals. So you leave your answer as half. Whoops. What's going on there? Oh, no. There we go. Half e to the 2x plus 2x minus half e to the negative 2x. Don't forget the plus c. If this was your exam, I'd probably not leave your negative power there, but I'd look at the number of marks as well. If it seems like I've used so many steps already, I might just leave it there, but I'll look at the number of marks in total. Okay, but never leave your answers with negative powers. So you'd rewrite that as 1 over 2e to the power of 2x instead. And if there's common terms for e to the x, then I would factorize it as well. But in this case, I'd probably leave it as it is. Yeah? Let's have a look at the second example then. Second example, say, very similar to what you did in chapter 9. To derive this, you can't derive them individually. It also means you can't anti-derive them individually in terms of numerator and then denominator. So you have to simplify it. Let's go with Erwin. How would you simplify this expression? What would you do? 1 divided by e to the x. What do you mean by that? Not sure? That's okay. Someone else? How do we simplify this fraction? Let's go with Charlie. How would we simplify this expression? What would you do? Very good. Separate into fractions because they both have the same denominator. So rewrite it like this. 3e to the 2x over e to the x. You've got a minus 5 over e to the x. Why do you separate it? Is because then you get your individual terms. Remember the rules I'm giving you. If you get individual terms, it's a lot easier to apply. Then from here, you've got to still simplify because there's still a problem. You've got a fraction on this one, you've got a fraction on this one. So what do we do next then? Let's go with Aryan. So Charlie suggested separate the fractions, which is true. That makes it a lot easier. You have two terms now. But what can you do to this first fraction? Very good. So you can simplify the e to the x. Okay, so you got 3, but since they both have the same denominator, and you're dividing, so then according to indices, we then subtract the powers. So 2x minus x gives you e to the x. So therefore, this should be 3 e to the x minus, now what about the second one? 5 over e to the x. You can't simplify it using indices, but you can rewrite it another way. How else can I rewrite this? Can I please have, let's go with Alicia. How can I rewrite this so that I can use antiderivative? What's another way of writing 5 over e to the x? Beautiful. 5 times e to the negative x. And then now, it's possible to antiderive using the rule I gave to you. Okay, so if you looked at the rule, we can see that both of them have k equals 1, and that one's a negative 1. So if you applied the rule, antiderive this, you should now get 3 times 1 on k, which is just 1, so it becomes e to the x, minus 5 times 1 on negative 1, e to the negative x, and don't forget the plus c. So So therefore it's 3e to the x plus 5e to the negative x plus c. So far so good? That essentially is the exercise for 11D and 11G. I've just went through the first rule with you, but essentially the other examples is then combining those rules. So using the same theory, you're trying to break it apart, find k, it's 1 on k, and to derive circular functions and then exponentials. Okay? I'm going to give you, let's say it's currently 12:37. I'm going to give you, say 6 minutes, so 3 minutes each to do example 3 and example 4, and then we'll have a look at our answers to see if it's the same. And then on the back page, it's just the final textbook question, just to give you a sense of how you'd problem solve. But that's essentially 11D and G. So for the students who aren't doing specialist, your skill in chapter 11 is just learning how to antiderive. Okay, so you got your rules, just like chapter 9, you learned how to derive functions. Then chapter 11 is learning how to antiderive. You haven't yet applied it yet. So you haven't applied to find areas between two intervals or areas between curves, but that's in the next 2 exercises. All right, team, let's pause the video.